Here is the main turning point to the motherboard because motherboard the stages S5 to S3 stage it reached. No, we reached, right? Because what are the things we got? We got S5 ash, S4 ash, S3 ash, then sys on from the IO, and what? susp ash from IO. These are the output from from IO, right? So now this is the turning point which I told you, no? Really it's a turning point because from S5 stage to S3 stage we reached. Now what are the voltage we got? 1.2 VDDQ, right? And then 0.6 VTT. This also we got, and 2.5 volts also we got. Using this, what are the sections will active? That we will check now. See, this is PCH side, UC1B SKLU. This is the memory part, okay, interleaved memory. So what it contains? It contains DDRA. It's a bidirectional communication channels, right? So when it will start, that we will check one by one. See, this 0.6 volts we got, right? So even reference also we got. DDR PG control one more voltage it releasing. So these all are output from PCH. See here also same thing. There are two channels. See this one, it's a B1 DDRA and DDRB. Okay. See the clock. These all will go to RAM slot. Okay. In RAM slot, what are the voltage we got? That we will check one by one. See, this is the RAM slot. It's a DIMM 1A. Actually, it's two part they made. It's a 1A and 1B. Both are 1, DIMM 1. Okay. See, we got 1.2 volts VDDQ. So it is in RAM slot. 0.6 also in RAM slot. 2.5 also RAM slot. Right. So here one more important point. See here DRAM RST. It will begin or not, that we will check now. See where it is. It goes to where? DRAM RST. See here. When it will start? That is the main question. When? Once you get the voltages 1.2 volts VDDQ, reference CACB, what is that? 2.5. Once you get all this, see prime also we got, right? DA and DB both we got. So once these all are fulfilled, then DRAM RST, RAM related reset will start. Okay. DRAM RST, when it will start? Once you get 1.2 and 0.6 voltage reference, all related voltage once you get, then DRAM RST will start. Okay, by the pull up voltage of 1.2 volts. Keep it in your mind, DRAM RST always pull up for 1.2 volts. So now confirmly we can tell the DRAM reset will happen now. After that, all this DDR related from CPU to RAM slot, the bidirectional will start, but it's not completely start because CPU is not yet turned on, right? So only the thing is the suspend to RAM S3 stage it will reach. So that is main important point. I'll repeat, S3 stage will start. Now we already got that VS signal, suspend related voltages. Okay, once that carried signals and voltages will generate, then S0 stage it will reach from S3 to S0, right? So now we will check what are the S0 stage. See here, so we got 5 volts always, 1.0 volts prime, and here sys we got, S4 we got, susp we got, S3 we got. So once this all the voltage 1.0 volts prime also we got, right? Once all we get, so finally it will convert the DC to DC. IC will convert to this output. So what is that? 1.0 VS VCC IO, and here 1.8 volts. It's a dual channel actually. So it's two channel. It will take input and it will get it will give output once we get the enable signal. Okay. So now what we got? It's 1.8 volts Vs. All Vs 1.8 volts Vs related. We will check one by one. Here the 1.8 volts is converted as AVDT. Here it has given, but anyway internally it is short, right? So AVDT, it's audio related voltages. Now that 1.0 Vs is VCCIO. See where it's going? It's a CPU power management. See CPU power A22. Okay. And also here, see here, it's all pin VCCIO. What are those? Here one and here many multiple pins, right? So here the voltages, it's 1.0 Vs VCCIO is converting as STU. Here in CPU power management 1, so the pin number G20. Here also it will be input. Now the 1.0 VCC STU converting as VCC ST and VCC SFR. Here the converted voltage VCC ST A18, okay, and anywhere it is there, so we'll check. See guys, it's a very important voltage because here SVID alert, the pull up carryable signal, it will carry the SAC SVID alert. So this voltage is the pull up. See here also same thing, VR SVID data and alert. So it means the processor is now starting to activate, right? Till now it will be in disable mode. It is active but still it is inactive, right? So now the signal alert and data is carryable by pull up voltages 1.0 V VCC ST. See here this voltages SKL CLN, it's a processor select. See, processor select these voltages. One more important thing is this voltage is converting as, it's carrying the thermal trip. See, if you won't get this voltage 100%, your motherboard won't turn on because it's a thermal trip ash, it's a carryable voltage. The one voltage should be there. When you press the power button, the CPU thermal trip will carry the 1 volts. So through the signal, through this pull up voltage. Here EC VCC STPG, this signal also carrying. Now the most awaiting important voltage plus 3 Vs. Okay. So what it will convert? What are the What are the signals it will carry? Those things we will discuss now. See the 3 Vs converting as PGPPA here. The 3 Vs carrying this SA0, SA1, SA2. It's a dim channel select one. See, for all it's a carryable. I mean it's a pull up voltages. Here it's a hat has given, but internally it's a 0 resistor. Here also same, that one previously what we saw, that is a channel A, here is a channel B, SA0, 1, 2, okay, total 3 signals. See, through this jumper, the 3 Vs converting as 3 Vs SSD, it going to SSD connector. See, the 3 Vs, if you don't have 3 Vs, then your SSD won't detect. Through this logic circuit, this 3 Vs is converting as 3 Vs touch. This 3 Vs touch in is converting as 3 Vs touch. Okay, this is a touch screen voltage. See, one more important one. You have seen that display part, right? That is the EDP power. So from where you will get? This is the main reason. Here plus 3 Vs is the input for this particular UG1. And enable signal is ENVDD underscore CPU. The CPU, the SOC will release enable signal, then this particular IC will start, then we get the output, then you will get the brightness. It's a LCD VDD signal to EDP pin. Here without enable, direct the VS signal is converting as VS camera. It's a camera input. Here is the gate for this N channel MOSFET, once this voltage comes, then your PCH PB HPD will convert as HP detect. Here is the HDMI socket, it's a clock and data, HDMI data. Here see, through this pull up, it's converted as PB HDMI. Actually, it's a HDMI port, it's a clock and data. Here is the VCC for CRT section. See, 3Vs. The CRT part, that VGA part will be there now, that also activated. Here the 3Vs is converting as CRT. For audio IC also, this voltage is required. See, this audio hash. Here the DVD conversion, that also 3Vs is required. Here 3Vs, see, SM clock 2, data 2, and here SCI. TPM section, see, 3Vs is converting as the TPM voltages, source voltage. See here, this 3Vs, the wake signal bidirectionally, it's working. Once 3Vs comes, this N channel MOSFET will enable, and this wake, it's bidirectionally will work. So somewhere it's converted as WLAN also. So this signal is carrying through this one, WLAN signal. See here, it's IO-BD connector, that USB card and some SDD power, something power LED. That external card will be there, no? Motherboard, in data board, I think so. It's a data board connector in motherboard. Here also 3Vs is available, pin number 6 and 7. Guys, it's a very important one. See, the fan speed, the signal through this Vs only, it's through pull up of this voltage, it's carrying. See, the fan speed signal. See here, it's a most important AND gate. So for this also, it's a input, the supply to the AND gate. See this, through this pull up, clock 3 and data 3 enabled. Somewhere it's converting as a VGA also, so that one is DACL THS is carrying out. Here we got 3Vs and here 1.8 volts prime. DGPU power enable. Once this signal will start, so then it will convert as VGA, 3Vs VGA. Okay, it's not yet come. Once it comes, then it will convert as 3Vs VGA. Here it's carrying that signal GPU power good. Okay, this one is VGA. What is that? CPU VGA IC, this one. Here it's a chipset, PCH. What is this? It's a control clock and control data. See here, SMPG control. See here, we got already 1.2 volts VDDQ, right? So now it's carrying this particular signal, SMPG control. Now the RAM section will active. Okay. Here it's one more communication, PCH SMB clock and SMB data. So communication started now. Means this is the, it converting as SMB data to PCH SMB data and clock. See here, it's already converted as PGPPA, right? So through this PGPPA, PM clock run hash and SRIRQ request, that also carrying. It's a pull up for these signals. Here not only SMB clock and data, here SML clock and data also it's carrying, means it's gate voltage. Once this gate voltage will come, this one will convert as EC SMB clock 2 and data 2. Guys, initially I told you keyboard reset when it will happen. See, here is the proof. The 3 volts Vs pull up resistor will come, then EC KB RST will happen. Keyboard reset won't happen in the beginning stage. Once you get this 3Vs, then only that keyboard reset will happen. Here, what are the signals carrying? Clock request PCI related all signals. It's a 4 and 5. LAN mini clock, mini card reader will be there. No, here CR clock request, VGA clock request, all pull up. Here the most awaiting PLT RST, the AND gate supply. Okay, when it will come, that time I will tell you, but now the AND gate is active. See here, Dave SLP1. This one you will see in bias editing mode. Okay, I'll tell you once I'll get this one. Okay, SATA LED, SATA GP02, ODD plug. These are the signal this particular 3VS will carry, and here this signal is coming out from the sock. Which section it is? It's a USB section. So 3VS is, that's it. Now we will check 5VS. Here 5VS touch. So somewhere it's converting as touch in and 5VS touch. Even 3VS also we got, right? See here, 3 volts touch and 5 volts touch is JD EDP signal, which I told you, no, in EDP test screen, if you are using test screen, that required 3VS touch and 5VS touch. So in here that connector is available here. Okay, so 3VS and 5VS. Here HDMI voltage, see here 5VS is converting as HDMI CMT 5V. Here speaker side, see 5VS is converting as AVDD. These all are used in speaker side. See 5 volts AVDD. Already we got 1.8 VS, right? So here PVDD and AVDD. Mute LED out, the mute signal. That one, it's audio mute or EC mute, that we will check out next time. So this is the pull up for this particular signal. Here is the 5 volts, which connector it is. It's a keyboard connector. Keyboard pin number 1 has 5 volts VS. See, when we get this keyboard on ash, so then this VS is converting as keyboard light. So this keyboard light, once VS will come, then keyboard light will glow. This 5VS is a pull up for VS HDD1. It's a hard disk section. Here is the HDD section. See, it's a pin number 1 and 2. Here it's a ODD section. It's a, what is that? DVD section will be there, no? DVD writer, that section. It's a 5VS is converting as 5 volts VS ODD through this 5 volts always. Here it's a pull up for plus fan 1. See here, it's a core driver IC. Core driver IC, its input to the driver IC 5VS. Okay, then it should get the enable and then power that CPU PWM section. Then this IC will active and you will get the VCC core. Before that, the source voltage VCC voltage will be active to PUZ2. Same, just now what I explained, it's a PUZ2, now it's a PUZ3. It's a correlated driver input. Okay, this VCC. Here it's a enable signal to this particular driver IC. Here it will carry the VGA VCC and PVCC. And here is the GPU IC input. See, 5VS and here also 5VS. Same GPU IC. See here also is there and here also it has come. That's it. So all VS related voltages I showed you. So what are the signals and what are the voltages, it will come. So now once again we'll recap the power rail. See, in this power rail, what are the voltage we got? We got RTC, reset from here to here. We got all the voltage. See, SLP, S4, SysOn, SUSP, S3, 1 VS VCC IO. After that we got these voltages 1.5 we should get. I didn't show you. That's a VGA section. Here 1.05, that also over, 5 volts over, 3 volts over. So finally we got EC, VCC, ST. Now the main thing is, once VCC, ST, PG we get, then IO will release VR on. So this voltage we got, right? So once IO release VR on, then what are the signals will generate, that we will check once again. Not once again, it's the first time. See here, VR on, the pin number is 85, IO pin number. Yeah, see here we are on. So it's going to CPU IC enable signal. Once we get this CPU IC enable signal, then here it's a two phase separate, one A is separate, one B is separate, total 4 phase IC, this one CPU IC, all will generate appropriate voltages. Okay, once this CPU IC get this VR on, so what are the voltage it will get? So it will get one by one, I'll tell you that VCC GT is the last one, it's a core, okay, core 1 and 2, it's a dual phase, right? So VCC core 2 and next VCC SA. Okay, I'm telling you that we are on enable comes, these all are the voltage will generate. See guys, here is the power rail. So according to this we got all voltages except this one. Now that also we got, right? So once we get that, we are on, this also we got. 1 minute. See here, so what are the signals will active now? Once we get this, we are on. SMPG control we already got, this one also we got. SA just now we got through the CPU IC, core we got, GT we got, VR power good. See, after these voltages till more are there, okay, those things I'm going to tell you now in briefly. So it will check that VR power good, PCH power okay, then CPU power okay. After these all system power okay will start. So after this acknowledgement will start, then finally the reset signal will happen, PLT RST. So that's it guys, here we'll conclude. Okay, in next section deeply we will go one by one. So till now what are the voltages we got from S5 stage 2, I mean it's a G3 actually, G3 stage to S0 stage. That's it. If anyone wants to join our PLC, you can contact us, already given in the description. My number is 8861880678. If you are outside, if you want to call me or chat me with WhatsApp or Telegram, it's a +91 you have to add. Okay, that's it. Thank you very much.